Okay, in this tutorial, we're going to add movement controls to the player object, and it's pretty simple. First, we need to create a player component. And I think that needs to be capitalized. Oh my gosh. That was a struggle. Okay. We have our player component, and then we need to create a system, and I'm going to call this system player movement. And we need quite a few different parameters on this movement system. So first we need the keys resource, and this is going to be in control of gathering that input from your keyboard. And then we need the time resource, which we need to access the delta from the time resource, which essentially is the time in between frames. So you multiply that by the movement of your player, and it'll create a smoother movement. If you don't use the delta, I believe it'll be very choppy. And then we need to write a query for the player. And we need to access the transform of the player. And what this is on the right hand side is a filter. So if we didn't have that here, our code would not compile because it wouldn't know what transform to get. There's plenty of different transforms. There's a transform for the light object that we created. There's a transform for the floor that we created and the camera. So we need to be specific about what transform we are querying for. Also, personal preference, when I write a query, I like to write the type of query that I'm filtering for, which is a player, and then I do _q for query. So that's just what I like to do. And this actually brings me to a good point. Before we continue on with the system, we need to add this player component to the player object that we spawned in the system below. So down here, we first need to wrap this player variable in a tuple. And then down here, do a comma. Let's go ahead and clean that up a little bit. A comma, and then put player in there. Let's see. This is messy looking. Let me fix this for just a second here. There we go. All right, no, I did something wrong here. Oh, no, I didn't. It's just an error because I haven't finished the system above it. Okay, now that we got that, we need one more query, and that is the camera query. I'm going to call it cam_q. And with this one, we need the transform as well, but we don't need mutable access, so no mute keyword required. And then we're going to wrap the filters in a tuple because there's going to be two filters here. We need the width, which we're querying for the transform with the camera 3D component. And this is going to be without the player component. So let's see here. I believe because in this same system, we're already querying for transforms in another query, we need to specify in one of these a without filter as well. So I decided to do it just in the camera query, but we're querying for the transform of the camera 3D component, and we're also being specific that it is not with the player component. I believe you will also get some type of conflict error if you don't specify this without filter. All right, those are the parameters that we need to write the system. And let's begin writing the system. All right, I'm going to iterate through these queries, or the player query, with a for statement. So I'm going to write for player transform. Actually, I don't need the tuple, so I'm going to get rid of the tuple. Player transform in player q dot itermute. And then now I'm going to grab access to that camera. I'm going to call it cam. So I'm going to write a match statement just for some light error handling here. So if okay, we're going to return the camera. If not, let's go ahead and print out an error message here. Those should be curly brackets or curly braces, not square brackets. Okay, now first we're going to create an empty vector. We're just going to call it direction. This is going to be the direction that the player is moving. And then here we're going to calculate the direction in which the player is moving. So I'm going to write some comments here to describe in which direction the player is moving. And that is a spelling error over there. So if keys.pressed, this is where that key resource is coming in handy. Keycode.w, we're going to add the forward direction of the camera using cam.forward. So this makes it really easy. And we're just going to do this for the left, right, and back directions as well. All right, now let's do the back. If keys.pressed, key code, what is back? S direction plus equals cam.back. Now let's do left and then right. If keys.pressed, key code A, direction plus equals cam.left. Then one more here. If keys dot pressed plus equals cam.right. And I don't want the y value, so the up and down in our case, to change for the movement. And I'm gonna actually I'm gonna leave it for now. That way you can see what I'm talking about, and then we'll come back and correct. So disregard what I was saying. All right, let me write something out real quick, and then I'll explain it. Oh, we did not write player transform as mutable. Okay, so on line 48 here, we're creating a new movement vector, and we're taking the direction that we calculated in the left, right, back, forward directions, and we're normalizing it. So that's basically reducing its value to 1. That way, whether you're moving diagonally or up or back or left or right or diagonally left, diagonally back, right, it will all be a constant speed. If you didn't have this normalize or zero function right here, if you didn't normalize your new direction, if you were going up and right at the same time, so you're going diagonally, you'd actually travel diagonally faster because you're pushing down on 2 keys. So this is basically eliminating that issue. And then 2 here, this is basically our speed multiplier. So to change your speed, you want to change this value right here. And then this is that delta that I was telling you about earlier with the time resource. This is basically bridging that gap from frame to frame and creating a smooth transition experience. And then we're assigning this new direction to the player transform dot translation. So this is essentially all we need. We're going to modify a couple things, but we should be able to plug this into our systems and see the effects. So let's go ahead and add this to our systems, and we're going to add it to a new one because this is going to be an update system. So it's going to run on every single frame, not just the startup. All right, now we can go ahead and run this. All right, now let's move our keys. And great. Okay, you can see that it's moving forward, but now you can see that it's moving underneath the floor. And that's because if you look at the forward direction here, I'm taking the forward direction of the camera, which in our case, it's a little bit angled down, right? So it's going down. And then same thing going back. It's angled down, so it's going to travel up. We don't want the Y value to change at all. We want to give it a sense of gravity. So to do that, I'm going to, it's very easy. All I'm going to do is before I make any of these, before I modify the current player transform, I'm going to make the Y value 0. So direction.y is 0. Now if we run it, you'll see that in whatever direction that I'm going, it's going to stay flush to the floor. All right, the last thing that I want to do in this video is having a magic number like this right here isn't ideal. We want a better way to modify that. And if we wanted to access that speed value in a different system, right now we don't have any way of doing that because we're hard coding some magic number right here. So we're going to move this value into a component, just like how the player component is up here. So let's create a new component, and we're going to call this one speed, and it's going to have a value here, a floating point value attached to it. So now inside of the spawn player system, we're going to also give it a speed of 2.0. So down here, we want to actually access that speed variable, but we need to insert that component into our player query here. So right now we're only querying for the player transform. Well, now we want to query for two things: the transform and the speed of the player. So first we need to wrap this in a tuple since there's more than one value. And we're going to grab the speed component here. And we don't need mutable access, so you can omit the mute keyword. Then same thing down here in the for statement. We're going to wrap this in a tuple, and we're also going to query for that player speed. I'm actually going to call it player speed because I like to be a little bit more specific about my variables. Now down here, instead of having a 2.0, we can say player speed dot 0. And the reason we need to put dot 0 here is because when you have a single value attached to a component here, so parentheses F32, that's how you access this single value in here. You could change it to like, let's see, value F32. So instead of accessing it like this, you would say speed dot value. But I'm just not going to do that if I only have one value associated with it. That's just a personal preference as well, but you can do whatever you'd like. Now let's go ahead and run this, and we should see the same exact results. Perfect. And just to do a proof of concept here, we can change this value to, let's say 5, something that'll be noticeably more faster. And then if we go ahead and run it, you'll see that it should be much quicker. And it is much quicker now. So that's a much better way. You want to try to avoid using hard-coded values like that as much as possible. One, because it's easier for you to access and change it when you need to. And two, the player you can make that so the player can actually access and modify that value inside of a game. So for example, like a speed boost or something, if someone acquires a speed boost, you can increase the value of that component briefly and the player will be much faster. So all right, well, that's the end of this video. I will see you in the next one.